welcome. My name is Josh Ford. I'm with Ben Kurrek. We're at Developer Relations for NEAR Protocol. And we're here to kind of talk about JavaScript smart contracts and how you can deploy them on NEAR. But before we get started, we actually have a special guest, Brendan Eich, creator of JavaScript.
Thanks. Hi, I just wanted to say a few words. Thanks for getting up early like me with the recovery drink. So it's awesome to see what NEAR's doing with JavaScript, with Quick.js, cross-compiled to WebAssembly, running in the nodes. So you have real JavaScript smart contracts. I interviewed with Lex Fridman. It's a 3-hour plus marathon, but it covered a lot of things about why JavaScript is taking over the world. And honestly, JavaScript was not meant to take over the world, but it's also improved over time. And part of the improvement comes from work done in the browsers, but increasingly, I think a lot of the improvements come from things like what NEAR's doing, and blockchain projects using JavaScript and embedded JavaScript in places where it wasn't expected. Obviously, Node.js in 2009 really started something big. So I'm just thrilled to see this kind of evolution because it is driven by real utility and use and real users and developers who are the users of the language. And that's what I think is most important. It shouldn't be academics or compiler writers, JIT compiler writers, who decide what the language should be. It should be the developers. So thanks to all of you if you do use it, and I hope those of you who haven't started take a look at what NEAR's doing. And thanks for coming. Thanks.
Thanks so much.
Thanks so much. Cool. Thanks. So yeah, who am I? I'm Josh. I started my IT career in 2003. I did a lot of tech support, network admin, stuff like that. And then in 2006, I traded my glassblowing or web design for glassblowing lessons. So I became a full-time glassblower for many years, and then decided to come back into tech in a creative role, and I just chose software development. So I enrolled in a 6-month intensive boot camp, graduated, and then in 2020, I joined NEAR on the developer DevX team at the time. And then, yeah, I've been with the protocol for about 2 years, and now I'm the team lead for developer relations.
Cool, yeah. So I'm Ben. I'm still in university. I'm a third-year engineering student at the University of Waterloo over in Canada. Love Canada. But yeah, so a little bit about me. I started my journey in blockchain about 1.5 years, 2 years ago when I co-founded a company called Fayyr. It's a charity NFT platform that's launching later this year. But yeah, we were discovering and doing a bunch of research as to like what chain we should build on, and we discovered NEAR. It aligned a lot with our values, the carbon neutrality, proof of stake, you know, all that amazing stuff. And so we decided to build on NEAR, and then I got offered a job and started as an intern, and now I'm full-time. So that's a little bit about me.
Awesome. Thanks, Ben. So yeah, this is going to be like an interactive workshop where, you know, if you want to have your laptop out, you can code along with us. We're going to take you through kind of what it, you know, 0 to hero-ish on how to develop a smart contract using JavaScript. There's a quick link here, near.ai/JavaScript. Take you to a link tree. That link tree will have a bunch of resources that you can reference throughout the presentation, as well as a link to the slides that we're going through right now. So yeah. I think I see someone still taking the QR code. Cool. Just want to make sure you guys got it. Cool. Brief agenda. We're just going to go over kind of what is NEAR, developing on NEAR. We'll talk about JavaScript smart contracts, and then we'll just get right into the code and start showing you, get hands-on on how to do it. We'll go a little bit over the NEAR ecosystem and then kind of next steps for you guys. So yeah, briefly, what is NEAR for those that don't know? We're a layer 1 blockchain. We're proof of stake, and we're also certified carbon neutral by South Pole, which I'm pretty proud of. So not only does our validator nodes and the infrastructure certified carbon neutral, but all the individuals that are employed out through Collective, all of our carbon emissions are offset by 3 different reforestation initiatives and rainforest protection initiatives through South Pole. We're almost infinitely scalable through sharding mechanism, which I'm pretty stoked about, allowing us to scale with ease. And we're pretty quick, about 1 to 2 second block production time. Average is about like 1.2 seconds, but sometimes up to 2 depending upon network congestion. And we're also interoperable with Ethereum using the Rainbow Bridge. We were the first protocol to create a trustless bridge to Ethereum, so you can bridge your ERC20 tokens, wrap them, and bring them over to the NEAR network. So it's almost kind of like its own layer 2 if you want to use it through Project Aurora. Well, I'm sorry, that's the second part. Project Aurora also does the Rainbow Bridge, but we're also EVM compatible. So if you have a Solidity smart contract and want to deploy on NEAR, you can use Project Aurora's virtual machine EVM compatible smart contract to deploy your code to and run. So building on NEAR, there are a few different dev environments that I just want to cover quickly to kind of explain, to help explain the JavaScript portion of developing on NEAR. If you want to build natively, everything is compiled to WebAssembly or WASM. We have 2 different smart contract kits for you to use. Either Rust is our kind of our primary language, or assembly script is for native development. If you want to deploy using Solidity, you can, like I said before, deploy your code to the Ethereum virtual machine that's on NEAR. It's kind of cool. It's like in WASM, we have a smart contract that has its own EVM virtual machine running. So it's like a little Ethereum universe inside a smart contract deployed on NEAR. And similarly, that's how the first version of the JavaScript smart contract environment is a JSVM. So again, there's a smart contract deployed on NEAR. It's a little virtual machine in which you can deploy your JavaScript code that's actually compiles to base 64. A few developer resources when building on the platform. Definitely docs. Check out our documentation. Go to docs.near.org. We have some examples, near.dev. Currently, we don't have the JavaScript quick start upload to this yet, but we'll, in that link tree, we have a link to the repository that we're going to walk you through. But this is a work in progress. We're going to be adding more examples too, but easy ways to get started with quick boilerplate projects when developing natively on NEAR. We have NEAR Explorer as a block explorer. I have the link to the testnet version. Mainnet is just explorer.near.org, and then testnet is the link above. And also the NEAR wallet. It's a web-based wallet. Allows you to interact with that on the platform. And again, the testnet version is wallet.testnet.near.org. And CLI, super easy command line interface that you can use to deploy contracts, work with, interact with smart contracts on the blockchain that uses a web interface called NEAR API.js. That's what allows you to connect your front end to the blockchain and wire in, your DApp to communicate with NEAR protocol. And it's the same thing that NEAR CLI uses under the hood. So again, we have a couple different smart contract SDKs. The first one is NEAR SDK AS for assembly script. It's similar to TypeScript. And the next one we have is NEAR SDK RS, which is our Rust. And that's the one that we recommend everyone kind of use for financial use applications. Just a very mature, it's a much more mature language than assembly script, and definitely will help you during the development to make sure everything is secure and properly coded. And then our new one, which is NEAR SDK JS. And we're going to talk a little bit about that. So again, comparing the native languages, Rust, pros, mature, well-supported, it's got a thriving ecosystem. But the problem that we've gotten a lot is that it's a little bit of a steeper learning curve. People take a look at it, they're a little intimidated by it, especially people that are used to JavaScript. So we've had assembly script for a while. It's easier for prototyping, easier for those who know JavaScript and TypeScript, but the cons are it's a little bit more of an immature ecosystem, and the errors that you get are a little bit harder to debug, and it can not be the best developer experience. So we chose JavaScript, and why? Well, we feel that it is the language of mass adoption. There's about 7 million JavaScript devs. It's over half of the developer community as a whole. So if we're trying to get Web3 to be adopted by a lot more individuals and to start coding and programming on our platform, we definitely think having a JavaScript SDK and the ability to develop smart contracts using JavaScript is going to be a huge game changer. Easy onboarding for Web2 devs that are curious about the Web3 space. They want to get started. They don't know how. They get a little intimidated by languages that they don't want to know. What's something that's familiar to them? JavaScript. So why don't we just create an SDK for that? And then, yeah, building dApps in a single familiar language is definitely something that people have been really excited about. So, yeah, with that, I will pass it off to Ben, who will take us through coding. Again, that's near.ai/JavaScript. And, yeah, if you want to take it away.
Cool. Yeah, so this is the link tree that if you, there's a bunch of information, so the presentation slides, the repository that we'll be using for this presentation, and then there's just a bunch of awesome links here. So for this, we're going to be using the Quick Start repository. So there's two options that you guys can go when following along here. So we've got a Git pod that you can just open up, and it'll build all the environments, install all of the dependencies and all that stuff. So you can use Git pod, or you can go and do it locally, which is what we'll be doing during the presentation. If you do decide to do it locally, make sure that you go through the requirements in the Quick Start. It's pretty simple, but yeah, that's what we're going to be doing for now. So I'm just going to open up my terminal here, and I'm going to clone this. And then also, if you do run into any issues, there are some people in the back, so just raise your hand and they'll come and try to help you out. Drew over there, he's got his hand raised from Pagoda, and then Dorian right over there also. So if you run into any issues, just raise your hand and we'll try to get it sorted out. But yeah, now that we've cloned it, let's go into the directory. And then from here, let's open it up in VS Code. Make it a little bit bigger here. So the file structure here is we've got a front-end folder, and then we've got a source folder. So the front-end is everything front-end related. We can spin up a front-end pretty quickly, and then it'll interact with the NEAR blockchain, but we'll focus on that in the latter half of the presentation. And then we've got the source folder, and this is actually where our smart contract lives. So if we open up that index.js folder, or file, we've got the contract here. So let's break it down a little bit. To start, we've got some imports. This is what's going to help you use and interact with the JavaScript VM. So we've got a couple imports here. The first one is NEAR bindgen. And so that's just a decorator that allows your contract to actually compile down to base 64. So we just put that right here at the top. The second is a NEAR contract. And so that's the parent class that your contract will derive from. And that essentially just allows your contract to be in the correct format such that it can compile down to base 64. And then we've got call and view decorators. And so basically all this allows you to do is specify for a call method anything that's going to be changing state on chain. So you could have a function that changes some part of the information that's stored. And so for that, you'd specify the call decorator. And then the second thing is a view decorator. And so this is used for functions that are going to return information from the blockchain. They don't need to be signed. No gas needs to be spent. It just allows you to query information from the blockchain. So these are all imported from the SDK. And then let's go through the actual contract itself. So the first thing is the NEAR bindgen macro. Again, allows you to compile to base 64. And then we define our struct, or our class here, right? So within your class, you've got a couple things. The first is the constructor. So this allows you to default some state. So in this case, our contract is a simple status message contract. What that means is it stores a message on chain that can be changed and can be queried for. So in this case, in the contract, we're storing this message property, and it's going to be defaulted to hello Web3 world when the initialization function is called. The second thing is called set greeting. So this function allows you to pass in a message, and it'll keep track, the contract will keep track of the message that you've passed in. So you can see here that it's saying this.message is equal to the message. So the contract will replace its current greeting with whatever's passed in. And then the last thing is a getter. Get greeting. We see that we have the view decorator, and all this is going to do is it's just going to return whatever message is stored on the contract. So here you can see return this message. So now that we've sort of analyzed the contract, let's go ahead and let's install the dependencies. So npm install. And so this is just going to install the SDK and NEAR API.js and all that good stuff that we need behind the scenes. So now that we've installed, let's go ahead and let's build the contract. So in our package.json, we've defined a super simple script that you can run, yarn build contract. So you can see here that it's created this build/contract.base64 file. So in our directory now, we've got build, and then we've got contract.base64, and this is actually what's going to be deployed to the chain. So from here, let's do what's called a dev deploy. So we'll do a NEAR JS. So NEAR is the NEAR CLI. This is what a lot of developers use when interacting with the blockchain. So NEAR JS, because we're interacting with a JavaScript contract. And we'll do what's called a dev deploy. What a dev deploy is, it essentially allows developers to quickly deploy contracts without having to go through the account creation process, right? So you can quickly create a contract or create an account, deploy a contract to it, and you'll get 200 testnet tokens. So it essentially just makes it super easy to deploy things to the blockchain without having to constantly be creating new accounts. So you can see here that we've got some deposit, right? And so, Josh, do you want to talk a little bit about what that means?
Yeah, so basically, when you're storing information on the blockchain, we have a mechanism called storage staking, and you have to pay for a little bit of storage. It's actually not paying for it, it's reserving amount of NEAR on the account to cover storage that's put on the contract. As you add things, you add more storage, add more NEAR tokens to cover the storage, and as you remove state, you'll actually be refunded the storage. And it's a mechanism, again, called storage staking.
Cool. Yeah, so now that we've deployed the contract, we can use the Explorer that Josh was talking about a little bit earlier. So if I go to that link, this shows the transaction, and it shows a bunch of important information that you can scroll through the execution process. But all we care about is that here it succeeded, and that the receiver was the JSVM contract itself. So let's go back to the code, and let's actually interact with this contract that we've just deployed. So the way that you interact with contracts is you use that NEAR JS, and you can either do a call or view method, right? So in this case, we're going to do the call method, and we're going to call our contract. Actually, before this, let's just export an environment variable to make our development life a little bit easier. So we'll copy this, and we'll export that. But yeah, so the very first thing that we always need to do is we need to initialize our contract. And so this is going to set some default state. In this case, we're going to set the message variable to hello Web3 world. So what we're going to do is we're going to do NEAR JS. We're going to call that JS contract, and we're going to call the method init. We're going to sign it with the JavaScript contract, and then we're going to add some deposit for storage.
Yeah, and basically what Ben's doing right now is just initializing the contract to create the initial state.
But yeah, so here we are. And now what we can do is we can query for that message that's currently on the chain. So we'll do a NEAR JS view on the contract, and we'll get the current greeting. We don't have to sign the transaction because it's a view method, and there's no gas that's going to be spent. And here we are, hello Web3 world. Now let's change the current message that's on the chain. So for this, we need to sign. So we'll do a NEAR JS call. We'll call the JavaScript contract, and we'll call the method setGreeting. In this case, we'll pass in the message as GoTeam. We'll sign the transaction using the account, the dev account, and then we'll attach some deposit for storage. And here we are. So now what we can do is we can actually just go and get that greeting again, and it should be changed to GoTeam. And here we are. So yeah, that's a super simple smart contract written in JavaScript. It's just a greeting message that can store information on the chain that we can change and we can query for at any time using the NEAR CLI. So now what we're going to do is we're actually going to code our own contract from scratch. It's just going to be a super simple coin flipping game where you can pass in either heads or tails, and it keeps track of points for each player. So what we can do is we can check out the skeleton branch. So in this repo, we'll do a git checkout. If I can type. Skeleton, there we go. And so then none of the folder structures changed. The only thing is that the contract here is now a skeleton contract. We've still got the imports that we need. We've got the NEAR bindgen macro, decorator. We've got the NEAR contract class. We've got the constructor. We've got a call method. And then we've got a view method as well. You'll notice, though, that we have a this.points, which is set to an empty map. In this case, we're just going to be mapping each player's points, or each player to their respective points. If they pass in the correct side, heads or tails, they'll get a point. And if they don't, they'll lose a point. So from here, let's go ahead and let's actually code the view method. So we'll start off by just saying if the player that's passed in, so in this case, we're passing in a player to check how many points they have. So if that player is in the points, we're going to return the points at that player. And if not, we'll just return null. Super simple, just checking if they're in the map, we'll return it. If not, we'll return null. From there, we'll actually go ahead and let's code the flipping coin mechanism, where they pass in a side that they want. If they got it right, they get a point, and if they didn't, they'll lose a point. So from here, the first thing we're going to want to do is we're going to need to get the current player. How do you do that? So in this, we'll add another import. And this is the NEAR object here. If you're familiar with Rust, this is sort of like the M variable in Rust. But for this basically just keeps track of a bunch of important information that you can use when writing your contracts, one of which is what's called the predecessor. And this is essentially just the account that called this method. So that's going to be the current player. So we'll do a let player is equal to NEAR.predecessor account ID. Right? So now we have the player. And then all we're going to want to do is just check to see if they're already playing. And if they're not, we'll just default their points to 0. So we'll say if the player is not in this dot points, all we're going to do is just set this dot points at the player is equal to 0. Now, the next thing that we're going to want to do is just add some logging. It's really important, in my opinion, to add logs just so that, for debugging purposes or anything like that, it just makes it easier to view information. And so what we're going to do, normally, if you guys are familiar with JavaScript, you would use console.log. But here, all you need to do is just env.log. So we're just going to log here that the player chose the side that's passed in. And this is going to get returned in the NEAR CLI when we execute the function so that we can see exactly what's going on. The next thing that we're going to want to do is implement that random number functionality. Now, a lot of people here might be thinking, well, why don't you just use math.random, or could you use math.random? And random numbers on chain is not actually a trivial operation, so we can't do that. So what we've done is we've actually abstracted all that logic out to a separate contract that's deployed to the JSVM. So we have our contract here, and then we have an entirely separate contract, which is called the random hub generator. And basically, it just returns, it has a function that returns either a 0 or a 1. And what we'll do is within this contract, we're going to execute a cross-contract call to that other contract. And using the JSVM, it's actually really, really easy to do that. It comes all packaged into this NEAR object here that we've imported from the SDK. So what we're going to want to do here is we're going to get the random number. And then we're going to say it's equal to NEAR.JSVM call. So this is saying that I'm going to call another contract on the JSVM. And so the actual ID of that contract is on random hub.examples.testnet. I'm going to call the method generate random number. And then I'm not going to pass it any args. And so all this is going to do is it's going to return to me either a 1 or a 0 at random. And now what we're going to want to do is we're going to want to check, hey, was it a 0 or a 1? If it was a 0, we'll set that to heads. And if it was a 1, we'll set that to tails. So we'll get the outcome as if the random number was 0, we'll set it to heads. But if it was not a 0, we'll set it to tails. So now we've got the random number, we've got the outcome, we've got the side that was passed in by the player, and now we can go ahead and we can increment their points. So all we're going to want to do is just check if the side that was passed in by the player is equal to the outcome. Then we'll add an mvlog. You get a point. And we'll say the result was outcome. From there, we'll do this dot points at the player is plus equal to 1. So this is if they got it correct. Now what if they didn't? So in this case, we'll add another log, env.log. You lost a point. The result was outcome. Spelling mistake. Now what we're going to want to do is we're going to decrement their points. But we don't want them to go below 0 because that's just demoralizing. So we'll just do this.points at the player is equal to, if they're currently at 0, we'll just keep them at 0. So if they're at 0, we'll just set them to 0, but else we'll set them equal to whatever they were at before, minus 1. So there we go. That's a super simple coin flipping contract, right? They pass in a side. If they got it right, they get a point. If they didn't, they lose a point. So now what we're going to want to do is we're going to build the contract again. In this case, we wrote a super simple script that allows you to deploy the contract to a dev account and do the initialization function all in one. So all you have to do here is run a yarn deploy. And so here you see that it built the contract, and then it's deploying to the dev account here. And then it's scheduling the call to initialize the contract. And there we have it. So now let's go and let us export another environment variable. And then from there, what we can do is we can try to view the points for the contract. So NEAR.js view, I'm going to call the JS contract, and I'm going to call the method viewpoints. In this case, the player is just going to be the dev account, so the dev account's playing on itself. But yeah, if we do this, it's null because it's never played the game before, right? It has no points, it's not in the map, it's just null. From here, let's go ahead and let's actually flip a coin. We'll call the JS contract. We'll call the method flip coin. We're going to pass in heads. We're going to sign the transaction using the JS contract, and then we're going to need to attach a little bit of deposit. This is because the very first time the map is empty, and we need to add that player into the map, and that's going to cost some storage because we're adding information into the contract. It's scheduling the call. We lost a point. The result was tails. And so we can't go below 0. So if we try to view the points again, it's just at 0. Let's go again. Hopefully we don't lose a point like 15 times in a row, but lost a point again.
Oh, lost a point.
Unfortunate. Let's go again.
Yeah, and every time he's doing this, signing a transaction, sending it to the blockchain, it's coming back, modifying state. This is all live on testnet. Everything that we've been doing so far.
Keep losing.
Oh, lost the point again.
It's addicting, eh?
Yeah. Come on, heads.
I got a point.
Yay!
There you go. So now if we view our points, we get 1. There you go. So yeah, that's a super simple smart contract. We just coded it here live, and we've interacted with it using the NEAR CLI. But now what we're going to do is we're just going to deploy a front end and see how you can interact with this contract from a front end. So from here, all we're going to want to do is run a yarn start. What this is going to do is it's going to spin up a super simple front end. It's going to deploy that dev account contract. It's going to initialize the contract, and then it's going to all be in the browser ready to go. So here you see that it built the contract. It's doing the deployment, calling the initialization function, and then it'll redirect us up to the front end. And there we have it. But I'm going to sign out because I've never done this before. But yeah, so this is a super simple front end. And basically what's happening is it's initialized. Actually, let's look at the code to show you what's happening here. So in the front end folder, we got a couple things. One of which is this utils folder, which contains some of the utility files and utility functions that are used to interact with the blockchain. So if I open this up, you'll see the very first thing is this init contract. And what this is doing essentially is it's just establishing a connection with the NEAR blockchain so that we can interact with it. The second thing is we've got login and logout functionalities. And what that's going to do is it's going to redirect us over to the NEAR wallet to approve that we're signing into this decentralized application. And then we'll have that account object ready to sign transactions. So if I go over here and I sign in, it'll redirect us over to the NEAR wallet. In this case, I'm going to go through the creation process real quick. If the Wi-Fi lets me. Let's go back. There we go. So let's actually just create an account real quick. So we can call this JSVM. It's not JSVM.testnet because that's the VM account. JSVM consensus. Go team. Reserve the account. I'll expose my secure passphrase to everyone here, but don't do that.
Don't do that.
What is word number 2? Monkey. Creating the account.
Creating the account.
And there we go. We've got the JSVM.testnet account. And what we're going to do is we're going to sign into our dApp with that account.
And by signing into the account, what it's doing is it's creating an access key, which is kind of one of the cool things about NEAR. You have these full access keys and function access keys that are different to kind of other chains. This access key is a function access key. It's just loading a little bit of gas on behalf of the account. It doesn't allow you to send tokens at all. It just allows you to use this key to pay for gas to sign transactions.
But yeah, there we go. This is our super gnarly front end. We've got no points. We're on the JSVM consensus.testnet account. We can choose what we want, either heads or tails. We can submit, which means flipping the coin. And then there's some other stuff here. But yeah, so what happens when we actually flip the coin? And also, how did it get this your points is 0? How does it know that? And so that is defined here in the utils file. So we've got this get points function. This is getting called when the app is loaded or when it's on the first render. And so what's actually happening here is it's getting the account from that wallet connection. So when we've signed in, we've established that connection, and we have a wallet connection. So we get the account associated. We then use that account to perform a view function. This doesn't cost any gas, doesn't require any deposit. It's just a simple view function to get information from the blockchain. So we'll await account.view function. We're going to call the contract that it's deployed to. So this is the dev account. We're going to call the function of view points, and we're going to pass in that the player's whatever wallet is currently signed in. In addition, we've got this super simple Boolean flag here saying that it is a JS contract. This is super easy to interact with your dApp from a front end, and this is the only thing that's happening behind the scenes to get that points. Now what we're going to want to do is we're going to check out the flip coin function. So what this is doing is you take in a side and you take in a points. Now the reason we're taking in points, I'll explain it a little bit, but the same thing where you get that account object from that wallet connection. You're going to await, instead of account.view function this time, we're going to do account.function call. This is because we're changing state on the blockchain, and we're attaching some deposit, and we're spending some gas. So await account.function call. Again, we're calling the contract that the coin flipping contract is deployed to. We're going to call the method flipCoin, and then we've got some arguments to pass in. In this case, we've got whatever side the player is selected on the front end. We've got some gas. In this case, this is 300 teragas. And then we've got some attached deposit. So what's going on here? So in this case, if the points are null, remember how we returned null from that view points? If the points are currently null, then that means that the player has never played before. They're not in the map, and when they play for the first time, that's going to cost some storage. So in this case, if the points are null, we'll attach 0.1 NEAR. But if it's not null, we'll just attach 0. And you'll see that because of what Josh was mentioning earlier with the function call access keys, those can only be used to call methods with no attached NEAR. So the very first time that we try to attach a deposit, it'll redirect us over to the NEAR wallet, basically saying, hey, this dApp is trying to send NEAR. Do you approve or no? But anytime after that, when we don't attach any deposit, you're not going to get redirected, and the user experience is awesome. And then once again, we've got that JS contract flag set to true. And that's basically it, honestly. Like, it's a super simple front end. And so what we're going to do is we're going to go heads, and let's hope that we get the point here. But yeah, here's the redirect to the NEAR wallet, basically saying, hey, look, you need to approve this transaction. It's costing 0.1 NEAR. And there you go. In this case, we lost a point. Didn't get incremented. Unfortunate, again. But yeah, so this time, now that I do it again, it's not going to redirect us because we're already registered. We've already set, and we're already playing. But yeah, we lost another point here. Unfortunate. It's not my day today.
No, it's not.
Lost another point.
Lost another point.
I'm going to keep playing until I get one. Oh, my Lord. Random numbers. There we go. Awesome. But yeah, that's a super simple front end that we created a contract for, coin flipping contract. We connected it up to the front end. We deployed it using the NEAR CLI. And so we've showcased two of the tools that you can use when developing contracts, either the CLI or the front end using NEAR API.js. And here we go. That's awesome. So that's everything from me on my end. And so I'll pass it back on to Josh.
Yeah, no, thank you so much for hanging out with us and coding with us. We definitely want feedback on this. This is a brand new SDK. We just released this. It's still under development, but we kind of want help figuring out the future of how we're going to move this, and we really value community input a lot. So please give us your feedback. Here are several resources. For developing on NEAR in general, just to shout out DevRel team, every day, Monday through Friday, we do office hours twice a day. Hang out in Discord, come hang out with us, go to near.chat, come to office hours, and yeah, hang out. You can ask us any questions that you want. You'll have live engineers that are on the team willing to help you out and kind of guide you through the steps if you have any questions about how to build, ecosystem questions, anything that we can do to help. We also have, near.chat dev support. If you want to async, ask us a question. The support channels in our Discord, we're really prompt with answering questions and trying to help people build. And then, yeah, we have a feedback link here for the repo itself for you to give us some feedback on what was confusing, what would you like to see, what improvements, how would you like us to shape this tool moving forward. It's super important, again, to us to build the things that we build for the community and shaped by feedback from the community. And then the last one is our community meetings. Each Thursday we have a webinar community meeting where we have different people from the team, both at Pagoda and NEAR Protocol, to kind of talk about what our new development is, give an update, and then also get feedback and questions. And the second to last Thursday, this near.ai/tooling meetings, just click on it, sign up. It's a webinar. It'll just send you a reminder email when the Zoom webinar will take place. And yeah, you can come ask questions live and speak to the core team. So yeah, we really value interactive feedback, immediate feedback, and yeah, just making us very available to our developer community to yeah, help anyone along the journey and show them Web3 and our platform. Yeah, after this presentation, we're going to be going to the NEAR meeting room, which is, I believe, 19A. It's down the hall to the right, around the corner here. Ben and I will be in there, along with Drew and Dorian, some other people from the developer relations team. We'll be just hanging out. If you have any questions, want to talk to us about anything, we're just going to hang out in that room, help you build, answer questions, and yeah, just chat with you. So feel free to come check us out. So yeah, with that, thank you very much, Drew.
Do you have time to answer questions?
Yeah. Do we have any questions? I don't know if we have a mic thing, but I guess you could just shout them out. We could kind of, yeah, absolutely.
So you wrote this smart construct, or you wrote the program using class components. I'm wondering if it's opinionated, or can you also write the same thing with functions?
That second part was kind of hard for me to hear.
I'm wondering if the library is opinionated, or if you can write the same program using functional components.
Oh, I see the question. Yeah, right now we only support class-based components for now, but
What was the question, please?
Oh yeah.
the question was functional components versus class-based components when writing your contract. And so currently, right now, we only support class-based components or contracts because your contract needs to derive from that NEAR contract parent class. But yeah, definitely feedback. I haven't even thought about that. So maybe if you could go ahead and just leave some feedback asking, hey, will this be supported, and when, what timeline? Like I would like this or I wouldn't like this. That would really help us and help us sort of narrow down our scope and sort of define our direction from here.
Yeah, everything's basic. Yeah, class component, and where you can play around is either a view function or change function. Either you're manipulating state or returning state, and you can program those two different functions in there. Did someone else have a question over here? Maybe. Oh, in the back.
Is the random number generated through a VRF oracle or something similar to that?
No, it's literally just, so in that NEAR object that you got the predecessor from, you can do the JSVM call from, you can generate a random seed, and then from that random seed, it's like a random number of characters, and then I get the index of that character and check if it's like below a threshold or not, and then return that.
Anybody else? Oh, in the back. Dorian on the spot. Thank you so much, Dorian.
Is there a limit to the size of a NEAR smart contract?
No.
Like if you have a bunch of NPM modules in your smart contract?
you can just load them up. It's pretty cool.
Okay.
That's not actually correct.
But okay, hang on. You can, okay, so like per deployment, you have an X amount, but you can keep adding to it. You can keep, like, your state can keep growing and growing, but you're limited by individual smart contract calls. So like 300 teragas is the limit.
In terms of storage, so your initial WASM or whatever file you deploy to the chain can not exceed 4.19 megabytes, which is like a huge amount. But that's just for initial deployment when you're deploying a WASM. But like after that, you can stake as much NEAR as you want to sort of maintain as much state as you want on the contract. So for initial deployment, it can't be larger than 4.19 megabytes.
But then you can keep adding to it, and you just have to pay for storage at a rate of 1 NEAR per 100 kilobytes.
Okay, and I had another question about TypeScript, and I noticed those functions you have to call by passing in a string, and I many times make typos when making strings because there's no type checker.
Totally.
So do y'all plan to add like typings where you have function definitions that literally just map to a NEAR call contract?
Absolutely, that's like one of the feedback that we've gotten, and I've also like been talking about, definitely implementing a TypeScript functionality so that way it's a little bit easier to work with, because right now you as the developer have to know what the arguments are and how to shape them. But definitely want to implement TypeScript, and we also are working on an ABI interface on NEAR that will show you how to interact with smart contracts and what arguments to pass and what you can expect as return results. Cool. Any other questions? It's kind of bright. Let's see. Cool. Well, thank you very much. We appreciate your time. And again, if anybody wants to come hang out in the NEAR meeting room, we're right down the hall. And feel free to reach out on Discord. We're super approachable and super accessible. So thanks again.